Alright, so more limits here in this video and really exploring that limit concept. We're basically going to go through just a bunch of examples and really try and hammer home this idea of limits and how we do that. Yesterday we looked at an example where we took the limit, or not really yesterday, I say yesterday as if you're watching these one day at a time, the last video. We did a limit as x approaches 5 of 3x minus 2, and we found that the limit, which was 13, was equal to the y value at 5. Sometimes that happens and sometimes that doesn't. That doesn't matter. It's not necessarily going to match the y value. In this case, if we tried looking at the y value, if we were to actually just plug in 0 into our function, and remember how we read this, just jumping back up to this, we read this as the limit as x approaches 0 of this function, x over the square root of x plus 1 minus 1. Okay, that's how we read that. If we were asked just to find f of 0, which is not what this is asking, f of 0 is actually what is the y value in x is 0, we would just plug 0 in for every x. And we'd have 0 up there in the numerator over the square root of 0 plus 1 minus 1. And if we work that through, the numerator is a 0, and in the denominator, 0 plus 1 is 1, the square root of 1 is 1, and 1 minus 1 is 0. We get 0 divided by 0. This is undefined because we cannot divide by 0. But that's not what our answer is going to end up being. Because our answer doesn't care about what is the y value at 0. Our question, what this little thing is asking us, what that limit is asking us, is not what is the y value in x is 0, but if we get close to 0 on our x's, do our y values follow a pattern that look like they get close to something as well? So all of this work that we just did doesn't matter. I mean, it's fine. It is correct as far as evaluating what f of 0 is. That's not what we're asked to do. So we have to be very, very careful with that. The way that we want to do this is we're going to make a table. Now, I'm going to go through and set up the table for you again, and then we'll talk about how you can make these tables much faster than by doing it by hand. So I have to get close to 0. How do I know that? My problem tells me that. That's what this portion right here is saying. Limit as x approaches 0. So I need to get really, really close to 0 in both directions. So both from the negative direction, from numbers that are less than 0, and from the positive direction, numbers that are bigger than 0. And so when I set up that pattern, I'm going to start with negative 0.03, because I like to go by hundredths. That's just my personal preference. And then we have negative 0.02, negative 0.01. We have 0 there. Ooh, there we go. Space it out a little more. And then if we keep on going, going to make the table just a little bit bigger, we would have 0.01, 0.02, and finally 0.03. So that's our table, and we're just going to plug these values in. Now, plugging them in can get really nasty and really messy, especially if we're doing it by hand. Plugging in, say, negative 0.03, I'm going to do it up here and then get rid of it real quick. If we were to plug in negative 0.03, we would have this fraction, and we would have 0.03 here, negative 0.03 there, and then we would have the square root of negative 0.03 plus 1, and then minus 1. And doing that by hand is nasty, because we would have to do this negative 0.03 plus 1, which is positive 0.97. Then we got to take the square root of that, and then we got to subtract 1 from it, and then we got to divide all that stuff. You don't have to do that by hand. Your calculator can do all of that work for you, and I'm going to actually show you a faster way to let your calculator do that. I went ahead and did all the work, so let me put the work here first, and then I'll tell you how I did it on my calculator. And so, poof, like magic, there are our numbers. Now, I rounded these. These actually go on a little bit further, but I rounded it to the thousandth place, 3 numbers after the decimal. And the reason why I did that is it made it easier to see the pattern. If I rounded to the hundredths place, 1.985 would round to 1.99. 1.990 would also round to 1.99, and then that could be confusing as far as trying to find the pattern. So I had to look at the values and try and determine where should I round to. Realistically, you don't have to round to anything. You could write out the whole number. It just finding the pattern could be a little more difficult. By rounding it here, it made it really easy to find the pattern. Now, I mentioned I did not do any of this by hand. There is a way to do this on your calculator. Different calculators are obviously different. I'm going to go through how to do this on your standard TI-83, TI-84, 84 Silver, 85. I believe the 89s also work like this as well, though the specific buttons you type in will be a little bit different. Those of you with Inspires, those of you with Casios, those of you with other things, look it up on the internet. I don't know how to set up those tables, and this is going to make your workload a lot easier if you can do it with your calculator. So here's how you set up a table on your calculator. On your TI, the first thing you need to do is type in the function as if you're going to graph it. So you type in the function under the y equals. Just like you would if you were to graph this equation. You type it right in there, but instead of hitting the graph right away, you're not going to do that. After you type that in, you're going to push the second button, and then you're going to hit second window. Second window should open up your table settings. It says above that, TBL set. Now in your table settings, there's 4 different things that you have to change. The first thing that it says underneath table settings is TBL start. That's asking where would you like the table to begin. That's going to change depending on what you're approaching. For my table that I just created, I started it at negative 0.03, and so that's what I typed in there. Whatever you're going to start with, that's what you'll type in there. Underneath that, you'll see the little triangle table. That triangle means delta, Greek letter delta, which means change. That's how do you want your table to increase. Do you want to count by 1s, by 3s, by 0.7s? How do you want to count? I want to count by 0.01, and I want to go up by 0.01, so I'm making that a positive. If I wanted to count down, I'd throw in a negative. Underneath that, it says independent, and then it says dependent. Those should always be highlighted on auto. That's what you want. You want them both to be on auto, not on ask. Auto means they're actually going to do it for you. Ask, you have to constantly say, hey, give me the next one, hey, give me the next one, hey, give me the next one. Okay. Once you do that, once you've got that all typed in, which is really just 2 things you're typing in, I'll highlight it here in red. You're simply typing in where do you want your table to start and how do you want to change the table. Those are the only things that you're typing in. Once you do that, you can find that table by hitting second graph. If you hit second graph, that will create your table, and your table will look just like mine, although your numbers won't be as rounded as mine are. Remember, I rounded mine just a little bit. And the other thing that you will see is at 0, it will say error, because it is an error, right? If I plug in 0 into the equation, it doesn't work out, and that's why it says error there. So once you've set up that table, now you're just looking at the pattern. So when we look at the pattern, again, you got to look at 2 patterns. You got to look at the increasing pattern and the decreasing pattern. So my increasing pattern, 1.985, 1.990, 1.995, hopefully we can see that they're going up by 0.005 every single time. When we look at the other pattern, 2.015, 2.010, 2.005, that's counting down by 0.05 every single time. So what that tells me is by following the pattern in both directions, by following the patterns, hopefully we can clearly see what numbers should logically go in that blank space where I wrote error. In that blank space, by following the patterns, the blank space should be 2. Is it 2? No, it's error. But the blank space should be 2. That's what we're trying to find when we're doing limits, not what the blank space is. What should the blank space be if we just follow the patterns? Since the blank space should be 2, then what that means, jumping all the way back up to the top of the problem, the limit as x approaches 0 of this thing is 2. That is the answer. Okay? It's not what the y value is. The y value is undefined. It's the limit. The limit is 2. Okay? And it's all about the pattern, and your calculator can create those tables. So let's take a look at a couple of quick other examples, and then we're going to get some homework. Let's move on to the next slide. All right, so magically moved on to the next slide. Here is f of x. F of x is equal to 2 as long as x is not 3. when x is 3, f of x is going to equal 0. Just for funsies, if we were to graph this, it's a pretty easy basic graph. If we throw an x and a y-axis here, just like that, our function says f of x is 2 always, except when x is equal to 3. So if I just get some tick marks in here, 1, 2, 3, I'm going to go out to 5. At least in that direction. It may as well go in every direction, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. This says that f of x is 2 all the time. So 2, it's always 2, except when x is 3. When x is 3, the y value is not 2. There's a blank space there. Well, it's not really a blank space. There is a hole there, and f of x is equal to 0 when x is 3, so we actually have a dot like that. That's what the graph looks like. Not that we need it, but it is information. The limit as x approaches 3 of f of x is not asking us what the y value is at 3. I can tell you what the y value is at 3. We'll write that over here. The y value when x is 3, not 0, when x is 3, is 0. But that's not what the limit's asking us. The limit's asking us what's the pattern. And so if we were to create a table, we can look at that pattern. Now this table's you can't punch on your calculator. You can. There's a way to do piecewise, but I don't remember. So you can either look up how to do piecewise. I wouldn't invest the time. Instead, this one's a pretty easy one. And so here comes the table. And poof, like magic, there's the table. So notice I'm approaching 3. So this time I just went 2.98, 2.99 because it was easy to see what's going to happen here. Notice I got the y values because I just apply the formula. The formula says if x is not 3, the y value is 2. Well, 2.98 is not 3, so the y value is 2. 2.99 is not 3, so the y value is 2, etc., etc., etc. Notice I did not put a y value at 3. We don't care what the y value is at 3. I know what it is. It's 0, but that's not how we do limits. We leave that one blank, and then we look at the pattern. When we look at the pattern, counting up from 2.98, hopefully you can see that the pattern would be 2, 2, and the next number, logically speaking, would be 2. If we look at the pattern counting down from 3.02, we got a pattern of 2, 2, so logically speaking, the next y value would also be a 2, and so regardless of the fact that the y value is 0, the limit is 2, because that's what the pattern says. It's all about the pattern, and that's that. It's a really easy example, but it can be very, very confusing, okay? So we have to be careful when it comes to limits. We do have a basic rule. As long as the function is a basic function, the limit is going to equal the y value. So let me get that up here on the screen. So, poof, magic. For basic functions, the limit as x approaches c of f of x is equal to the y value, f of c. For most functions, that's true. The very first one we looked at on the last video, that was true. With these functions, they weren't basic. Piecewise defined functions are never basic. Even though this one we just looked at is a pretty easy piecewise function, it's still not basic. The y value was not the limit. The y value, again, was 0 when x is 3. The limit is 2. But you have a basic function. So what do I mean by basic? Polynomials are basic functions. Simple, like sine, cosine, those are basic functions. Functions that have fractions in them tend not to be basic. If they involve more than one thing, a square root and adding and subtracting and multiplying, not basic. But if you got just a basic function, usually the y value is the limit. But that doesn't matter to us. For us, we do the table. You got to do the table every single time. When you do this homework assignment that I'm about to give you, I expect to see tables. You don't have to do them by hand. You can let your calculator do them. You need to write them down for every single problem. Otherwise, I won't give you credit. So here comes the homework. All right, so here's the first part of the assignment. The next video, I'll give you the next half of the assignment because there's a couple other things we need to go through. Page 768, 11 through 31 odds. So it's not a ton of problems here to start with. I do have more that'll be coming from the section. And 11 through 31, you are simply using your calculator to create the table. Write the table on your paper and then tell me what the limit is. If all you do is tell me the limit equals 5, I will not give you credit. And if you don't get credit for one assignment, you don't get the 10% grade bump. You need to do every problem and every assignment. So make sure that you show me tables for problems 11 through 31 so that you can get the full credit. Until next time, stay safe and stay healthy.